Welcome to another session of Biomedical Instrumentation Lab. We're going to be building an spirometer. So we're going to be applying a switch to our project to get familiar with an LCD and use a differential pressure to measure flow velocity and calculating volume. So this is a spirometer in action. This is a switch. As soon as I press it, I enable the serial communication. This allows me to make some internal calculations in the Arduino software, as I'm going to explain a bit later. I need to press the switch and then blow. The sensor will then send voltage to the Arduino, and Arduino is plotting this increase in volume that we are seeing in the screen. Then Arduino is calculating the area under the curve of this plot, which this is displayed in the liquid crystal display as milliliters. So essentially Arduino is calculating how many milliliters of air I'm blowing. In this case is around 1 liter. Okay, something I'm doing in this project is that I'm joining power and ground into one unit, so my circuit looks less messy, so it's more tidy and organized. So I'm simply with this slip that will shrink under heat, I put the two ground and power. Once it's like that, I'm just going to apply heat with a hair dryer. So, and then this will shrink. So this is a finished cable. So we can see it has the blue there and the red, so I can differentiate it. And the purpose of this is to make the circuit much tighter. So this particular bit will power the sensor, so power of the sensor and the ground. This way the circuit looks much tidier. There are only, as you can see here, 3 double cables. So this one power the board, this one is powering the LCD screen, and this is power of the sensor. Obviously power and ground, so they are in pairs. And the rest of the cables, well, this is to get the output of the sensor, the purple one, and the other one is to ignite an LED operating the program. So this is how the sensor looks like. I have my LCD screen there. So this means every time you see a thick black cable, that means it's power and ground. Power and ground LCD, power and ground sensor, and power and ground of both. Okay, we're going to review the codes for reading the sensor. This code, I'm going to show you 2 codes. This is a basic one to read any sensor. Remember, there are 2 functions, the setup and the loop. In the setup, I'm simply initializing the serial ports at this baud rate. In the loop function, I'm reading the sensor value, so I'm declaring this variable, sensor value, and it's going to be equal to the analog read function in the pin 0. Then I'm converting it into voltage and sending it to the serial. So yeah, let's upload that to Arduino and see. So let's plot what the sensor is delivering. So that essentially is a value near 0. I'm going to blow through the device. So I'm going to blow a bit stronger. It's almost, I like to reach 5 volts. Let's see. If you see, it's not really 0. So I'm going to plot now the values to print the values. So that's the value on when there is no flow. When there is flow, so when there is no flow, is giving me around 18.18 volts. So what I'm going to do because all the calculations rely on this first value, I'm simply going to add a minus 18 here, minus 0.18. So whatever is this operation minus 8.18 volts. Print the values just to see if that helps. So yeah, it's almost zero, sometimes 0.01. So it's doing what I was expecting. Yeah. So looks like we are ready to start converting this value, this voltage value, into pressure, velocity, and volume. So remember this 0.18. I have my code that I created. So essentially, it's a bit full on this code. It has the liquid crystal libraries. I'm using two pins, same as before, sensor, but also I'm using a button to activate the code. So when I press the button, it will ignite a LED, but also this part of the code where if the button state is high, this part of the code that calculates the pressure and the velocity is enabled. And then obviously I declare the variables for pressure, flow rate, ratio of diameters, etc. All the Bernoulli equation that we saw on class. All this is essentially sending the liquid crystal values. So remember, we add we add 0.18 to the volt calculation value. Then once I have the volt calculation, I converted it into pressure through the transfer function that I obtained from the datasheet. This variable here is the datasheet says is a compensation error, so I obtained it through trial and error. Printing the value of velocity, so this one, that when there is no flow, it should be near zero. It's not zero, but so pressure is simply function of the voltage that we obtained from the sensor, and a few constants there. Once we have the pressure value, we convert that pressure value into velocity, thanks to the Bernoulli equation that involves density and the ratio of diameters. So this V2 is then converted into volumetric flow rates with the areas. So remember, volumetric flow rate is simply velocity times area. And then this value is too small because it's in cubic meter over seconds, so international system. I converted it into milliliters per minute with this factor, with these factors here. So then I'm calculating that, I'm integrating this to calculate the volume. Remember, this is the integral on time every time I'm going to blow. Because there is a value that is the sensor is giving me, respectively, if I'm blowing or not. I'm simply saying that if the value of the flow rate is bigger than 2 milliliters per minute, then the calculation of volume starts. And then, I'm sending that value to the serial, and of course the integrated volume through the LCD. I have these commented lines for debugging. Sometimes I was sending the velocity directly to the LCD to calculate this value here, trial and error. So I modified that value until I reach a very small value of velocity. We are sending volumetric flow rate in milliliters per minute. almost zero. As soon as remember, this is going to be enabled through the codes. Yeah, I think I have not uploaded this yet, so I'm going to upload this one. I'm going to show you why I realized it was not the real code. This code enabled the serial communication only when the button state is high. So you'll see now. Serial plotter, we don't have any until I have pressed the button. Hopefully you can see the LED, and that's my value. As soon as I release the button, there is no communication, or there's no print value there. That allows me that as a user, as a patient, I'm going to blow and at the same time press the bottom LED to have a consistent calculation of 3 seconds or 4 seconds, etc. So and at the same time, my LCD is displaying how much volume, obviously calculated, I blow. So 270 milliliters, which it has the correct order of magnitude. If you see a can of Coke is 370, so probably blowing 5 seconds it will be enough to fill it with air. And this number is on the same level. Of course, we need to calibrate this sensor somehow. And I'm imagining maybe blowing with balloons and then that volume taking it into containers with water and then measure how much volume we displace. Could be a good way to calibrate this. But at least as it is without calibration, is giving values on the order of magnitude. So I'm going to do it again. See how simply when I press, there is no displayed calculated volumetric flow rates. It's almost zero. When I blow, so that's the pressure value converted into through all the constants to volumetric flow rate. And of course, the integrated value is being zoomed here. So I have blown 550 milliliters of air so far in this exercise. So of course, if there is a protocol, a routine of evaluation patients, we can define how much time and maybe the intensity as the patient blow as hard as you can, and then have some statistics, do it periodically every week, every day. If there are patients with weak respiratory systems or after a condition, we can study the evolution of the respiratory system. So that's essentially how the spirometer works. Hope you like this project.